Gravity. It's the invisible force that's tugging at you right now. From the tiniest grain of sand to the colossal stars in distant galaxies, everything with mass is locked in this cosmic dance of attraction. Newton saw it as a force, but Einstein showed us that gravity is more than that. It's the very curvature of space-time itself, bending reality around massive objects. But what if gravity just vanished? No more oceans hugging coastlines, no planets circling stars, no you standing on this spinning ball we call Earth. It's a mind-bending thought, isn't it? Fear not, gravity isn't going anywhere. No magic, just physics. So what exactly is this mysterious force we call gravity? At its core, gravity is one of the fundamental forces of nature, an invisible hand that pulls objects with mass toward each other. It's the reason why when you drop your phone it falls to the ground instead of floating away into the cosmos. But here's the kicker. The more massive an object is, the stronger its gravitational pull. That's why a planet like Jupiter, with its enormous mass, has a much stronger gravitational field than our relatively tiny Earth. It's like comparing the pull of a sumo wrestler to that of a feather. There's simply no contest. Gravity is the unsung hero of our everyday lives. It's the force that keeps us firmly planted on the ground, preventing us from drifting off into space every time we take a step. It's what holds our atmosphere in place, creating the blanket of air we breathe. And let us not forget about water. Gravity is the reason our oceans do and just float away, leaving Earth as dry as a bone. But gravity's influence extends far beyond our little blue planet. It's the cosmic choreographer, orchestrating the elegant dance of celestial bodies. Planets waltz around stars, moons pirouette around planets, and entire galaxies swirl in cosmic ballets, all thanks to the relentless pull of gravity. Now, let's dive into the mind-bending realm of Einstein's theory of general relativity. Einstein proposed that gravity isn't just a force. It's a consequence of the curvature of space-time. Imagine space-time as a giant rubber sheet. Massive objects like stars and planets create dents in this sheet. Other objects then roll along these curves, which we perceive as the force of gravity. But hold on, it gets even crazier. Gravity messes with time too. In stronger gravitational fields, time actually ticks by more slowly. This isn't science fiction. It's a real phenomenon called gravitational time dilation. It's how clocks on satellites need to be adjusted to account for the weaker gravity in orbit compared to Earth's surface. Now let's indulge in a thought experiment. What if gravity suddenly decided to take a cosmic coffee break? The results would be, well, out of this world. Without gravity, everything not firmly attached would start floating freely. Imagine waking up to find your bed, your cat, and even your morning coffee hovering in midair. It might seem fun at first, but the novelty would wear off quickly when you realize there's no way to stay grounded. Our atmosphere, gone in a flash. Without gravity to hold it in place, Earth's precious blanket of air would dissipate into space faster than you can say, where did all the oxygen go? We'd be left with a barren, airless rock. Not exactly ideal living conditions. And speaking of living conditions, the human body would be in for a rough time. Our muscles and bones have evolved to work against gravity. Without this constant challenge, they'd weaken rapidly. Astronauts on the International Space Station already have to exercise for hours each day to counteract the effects of microgravity. In a gravity-free world, we'd all face similar challenges. Water, that essential ingredient for life as we know it, would behave in ways that would make your head spin. Instead of flowing in rivers or filling oceans, it would form floating blobs, drifting aimlessly through the air. Forget about pouring a glass of water. You'd be chasing liquid spheres around your kitchen. On a larger scale, the absence of gravity would spell doom for the cosmic order. Planets would no longer orbit stars, moons would drift away from their planets, and galaxies would unravel like cosmic confetti. The universe as we know it would cease to exist, replaced by a chaotic soup of unbound matter. Life itself, in all its wondrous complexity, simply wouldn't exist without gravity. This fundamental force is crucial for the formation of stars, its planets, and the intricate ecosystems that thrive on Earth. It drives weather patterns, ocean currents, and even the cycles of plate tectonics that shape our world. Gravity is more than just a force keeping us grounded. It's the invisible architect of the universe. It shapes the cosmos on the grandest scales and influences the tiniest particles. From the apocryphal apple that inspired Newton to the gravitational waves detected by modern observatories, our understanding of gravity continues to evolve, revealing new wonders about the nature of reality itself. So the next time you feel the Earth's pull beneath your feet, take a moment to appreciate the incredible force that's holding our world, and indeed the entire universe together. It's not magic, it's not mystical, it's just physics in all its awe-inspiring glory. No magic, just physics. And that's the gravity of the situation.
Stay curious.